Well, Assalamu alaikum dear students, I'm Engineer Abdul Basit and we are in lecture number 23 of week 12. Okay, the topic we are going to discuss here today is actually the continuation of that previous topic, and previous week we have started to discuss the classification of soil. Okay, so there we discussed the textual classification system and some part of this AASHTO classification system as well. And in today's tutorial we will talk about that remaining part of the AASHTO classification system, and we will solve, or you can say we will classify a sample of soil with the help of AASHTO classification system, and then we will talk about the unified classification system as well. Okay, so straight away coming to the AASHTO classification system remaining part. So here it is, that was the table we have discussed in the previous tutorial, that in AASHTO classification system we use basically two tables. Okay, number one is for this table is for granular soil, okay, granular material, and this table is for silt and clay material. Okay, so the condition for the granular material is 35% or less of the total sample passing through 200. So you can say in all the tables number 200 sieve is showing us that maximum limit is 15, 25, so neither of these is greater than 35%. Okay, then we will classify, in this table we will classify the soil basically in A1, A2 and A3 group, and then we have the subgroups as well available here. Okay, in the next table, that is for silt and clay, like for fine materials, here you can see all the number 200 sample, you can say the number 200 sieve is giving us the passing percentage greater than 35%, which is 36 minimum, 36 minimum and 36 minimum. So this table is actually for that fine materials. Okay, now in this table we have this 4 classification system, and in A7 we can have A75 and A76 as well. So this is that condition for A75 and A76, which is like when it will be in A75 and when it will be in A76. Both of these are actually A7 group. Okay, so when the plasticity limit, or sorry, plasticity index is less than or equal to liquid limit minus 30. Okay, and similarly this plasticity index when it is greater than liquid limit minus 30, so then it is will be A76 group. Okay, so this is actually like once you classify the soil against these numbers, and you see that the soil is very much similar to this group A7 group, all the values that are giving for their soil sample is like falling in this column, so then it will be A7 group. Then you will decide whether it is A76 or A75. So for that you will use this equation and then this equation. So you will see which equation is getting satisfied, so either this one or this one. Okay, so if this one is satisfied, then you will see this is A75. So you will see it in an example as well, that will be more clear to you after that. Here it is a chart. Okay, this is again for AASHTO classification system, and this chart is like showing the same values which are shown here in the tables. Okay, so like you can say that whenever you this is actually drawn between two values, that is liquid limit and plasticity index. So these are the two parameters that are like used to draw these values, these charts, these lines. Okay, now you will see if your soil is like of a type that it is falling in this rectangular area, that is between this blue line and this blue line and this black line, then it will be A26 and A27, either of these. And if it is falling in this triangular area, then it will be A76, and if it is falling in this triangular area, then it will be A27, and so on for this triangular area, rectangular area, and for this rectangular area. So again, but this chart is actually not classifying the soil properly as we need to, because in the table we do have a lot of information available. Here we can see that A26 and A6 groups are not being separated from each other. Okay, these are actually lying in the same area. so you can say that you cannot justify which group it is. It is showing us two groups at the same time for the same sample. Okay, so then it is not much clear as compared to their table one. So okay, now coming to the group index. So if you want to evaluate the further quality of the soil as a highway subgrade material, so you have to use that group index equation. So you can see it from that equation that it is a very long and a very varying type of equation, but it is not. Okay, it is so simple. It is not that complex equation. It is like having few values which are like you are very much aware to these values. That is the number 200 passing percentage, liquid limit, and plasticity index. So these three values will be used in here in this equation, and simple calculation as well. Then if you classify the soil under these groups, A4, A5 and so on are in these groups, A1, A2, A3, A1, AB, A1A and so on. If you classify the soil under these groups, then you will also find out the group index for that, and you will classify the soil in the form of like this is A4 soil, and in the parentheses you will write the group index alongside. Okay, so this will give you more information as compared to this singly showing us this A4. Okay, so A4 is giving us limited information, and when you calculate that group index as well, so this will give you further more information, and that will be then utilized to find out the engineering properties of the soil. Okay, so then here it is how to use this group index, what type of terms we have here. So group index is F200 minus 35 then multiplied by 0.2 plus 0.005 liquid limit minus 40 plus this is separate term, and plus again this is again a separate term which is 0.01 multiplied by this term which is F200. So you can say the percentage passing through number 200C minus 15 and plasticity index. So you can say we have two terms in this group index equation. The first term is basically depending upon the liquid limit. The rest of the things are the constant digits are like different, and it will give us a different value, but the variables are like only the liquid limit is here the variable and the F200 is the variable. Okay, but here F200 same in the both equation. Here it is the difference of plasticity index only. So you can see that we have that group index divided in two terms. One is based upon the liquid limit and the other one is based upon the plasticity index. Okay, so here therefore you can say this is the partially plasticity index, and this is partial this is liquidity index, and this is partial plasticity index. Okay, this is again the same equation. Okay, all the terms are explained here, but here it is like written that this first equation, which is based upon the liquid limit, is partial group index determined for liquid limit. Okay, this is partial group index of the liquid limit, and this one, the second term, this is actually the partial group index of the plasticity index. So this is the difference between these two terms. Why I am talking about these two terms separately, you will get to know now. Okay, how to calculate the group index. Okay, what is actually the tactics we use to determine the group index. So simple, use that equation and put all the values you have for person passing through sieve number 200, and also the value for the liquid limit, and you will also have the value for plasticity index. You will put these values in the equation, and you will calculate what figure we are getting now. Okay, so if you are your equation 1 is yielding a negative value, okay, this equation is giving us a negative value, so you will consider the group index as 0. Okay, because there is no negative value for group index. Whenever it is a negative value or for group index, you are getting a negative digit, okay, less than 0 value. So then you will consider the group index is equal to 0, and you will write it as like, for example, A to 6 is that group you have decided from the table, and then in the parentheses you will write the group index which is 0. Okay, similarly, if the group index calculated from equation 0 1 is rounded off, here it is, that's important thing. Number one, negative value should be rounded off to 0, and the remaining like decimals will also be rounded off. For example, you are getting a group index value equal to 3.4. Okay, so then it should be rounded to the nearest round value, round figure, whole figure, okay, which is 3 for this case. 3.4 is closer to that, or the nearest whole digit for this is 3. And similarly, for 3.5, it should be rounded off to 4. So you will neither write 3.1, 3.2, 3.3, 3.4, 3.5, not in decimal. Group index should always be in the whole number. And how to round it off? This is the technique. There is no upper limit for the group index. Group index can be of any value, but it cannot be negative. Okay? If it is negative, you will round it off to 0. Okay? Then the group index of the soil belongs to, if a soil is classified in A1A, A1B, A24, A25, A3, this will always be 0. Okay, you will first classify the soil according to that AASHTO classification system, and you will see in which group it is actually falling in, and then you will decide, like for example, this soil sample is from A1A. So if that group is from either of these groups, A1A, A1B, A24, A25, A3, so you will use 0 for that. Okay, no need to calculate the group index. Then you will see it is like one of these groups, so then always the value will be equal to 0. No need to calculate the group index. But when the calculating the group index from soil that belongs to A26 and A27, so this is a bit complicated thing. If you getting a soil that is like falling in A26 group or A27 group, okay, then the partial group index for plasticity index will be used. You will not use the whole equation. You will not use this whole equation. You will use only this part of the equation, which is the partial group index for plasticity index. Okay, so you will use only this part, this half, this one term. Okay, why? When it is falling in A26 group and A27 group, and for these groups no need to calculate, always the group index will be equal to 0. Okay, so this is like something. Okay, this is important thing. In general, the quality of the performance of the soil as a subgrade is inversely proportional to the group index. Group index is inversely proportional to the performance of the soil, okay, of the subgrade. So if your group index is like yielding a higher value, so it means your soil is your soil quality is poor. Okay, if it is giving us a low value near to 0, then it will be like your soil is of a good quality, and it can be it can give us more bearing capacity and so on, more better engineering properties. Okay, again coming to a simple numerical on that AASHTO classification system. So here it is. How can we do it? The result of a soil size analysis of a soil are given like in this equation. So simple. A percentage of the passing number 10 CU is 42. Percentage of passing through number 40 CU is 35. Percentage of passing through number 200 CU is 20. Okay, the liquid limit and plasticity index of minus 40 fraction of the soil are 25 and 20 respectively. Classify the soil in AASHTO classification system. So you have to classify this soil sample which is having these properties in AASHTO classification system. How will you do it? Simple. The first step is to decide which table to use. Okay, so either to use the table for granular material or to use it for of the clay and silt material. Which one should be used? So here it is the answer for that. Number 200 cu passing is 20 given. Okay, so if it is given as 20, so it means it is less than 35, so it is a granular material. You will use this first table, which is this one. Okay, then coming to these next values, next we have that percentage passing through number 10 cu is 42, okay, and number 40 cu is 35. So these are the second properties we have to look in the group for that. Here it is, this table should be used. Then 42, here it is 50 maximum is required, so it is okay. Okay, again I forgot for 40 that was for 40 that is 35, so 42 and 35. Coming here again, 42, this is okay, this is 35 maximum, 30 maximum, and our value, required value is 30, so we cannot use it now. Okay, then coming to this one, no limit for number 10, and it is 50 the maximum value, so you can use this one. Okay, 25 maximum is the range. Okay, and we have that value which is for 200, that is 20. Okay, so again this group is okay. Now coming to these liquid limit and plasticity index. Okay, so moving on to the statement again, here it is, of the soil is 25 and 20 respectively. Liquid limit is given and plasticity index. Liquid limit is 25 and plasticity index is 20. So again 20. This is 6 maximum. So you can use you cannot use either of these groups. Again moving on, this is 51 minimum. It is not okay. Again moving on, this is no condition for the first two. 35 maximum, it is okay. 40 and 10. So we will have 10 maximum, and that is 20 given over there, not okay. 40 maximum, okay, and I think that is okay, and this one is 11, and this is 35. So if I am not wrong, this is A to 6 group. Let me see these things again. This is given here 25, this is 20, and this is falling in A1B. Okay, here it is 25. I thought it is 40. Let me move in again. This is here it is no limit, and this is 20, so this is not applicable. 60 is the max, 6 is the maximum value, and plasticity index in the statement that is given over there is 20. Okay, this is 20, plasticity index is 20, and that is 6 maximum, so it's definitely not falling in A1B. This is wrong interpretation here in this table. Okay, this is falling in somewhere in the other groups. Okay, so you will look for that group, and then you will decide the group index as well. So if it is in A1B, then it will be, look at this thing here. It is the calculation. You can see that it is plasticity index, but in the statement here it is already written that plasticity index is 20. So this statement is a bit wrong. You can see that this is not of that type. This is not plasticity index. This is actually plastic limit. Okay, so from calculating this, plasticity index will be equal to liquid limit minus plastic limit, which will be equal to 5. So then it will fall under the group index, that is 6 maximum, and then it will fall in the group index A1, sorry, in the group A1B. Okay, so now coming back to the same thing, that rules for the group index. Here it is A1A and A1B. So whenever your soil is from A1A and A1B group, so then it will be always 0. Okay, so you will write it here, that is equal to 0. Similarly, coming to this thing, this next numerical. So here we have the values that are given here. Yes, let me write it first. For 95% of the soil passing through number 200. So this is 95%, so definitely we will use table number 2. Okay, and has a liquid limit of 60 and plasticity index of 40. So this is liquid limit is also given, that is 60, and plasticity index is given, that is 40. Okay, now coming to that solution, so we will look in that table number 2 first of all. Moving in, here it is, table number 2. So first of all, the first condition is satisfied, that this is 95% passing through sieve number 200. So this is this table, and okay, there is no condition for number 10 and number 40 sieve. Okay, so no need to use these conditions. Straight away moving to liquid limit and plastic limit. Okay, so in the first group A4, that is 40% maximum, and liquid limit in the statement given is 60. So definitely not satisfying this condition. It is not falling under this group. Then moving on, here it is 36 minimum. Okay, then this is 41 minimum. 41 minimum, so you can have any value greater than 41, which is here in the statement we have, that is 60. So it is like this condition is okay. Then plasticity index is 40, and here we see that this is 10 maximum. So again, this is not satisfied. Moving in, A6, A36, 36 says okay, 40 maximum. This is 40 maximum required. Okay, you cannot have any value greater than 40. So here we have, that is 60, so we cannot use it, and then this group is not satisfied. This is 41 and 11. So liquid limit is 41 minimum. Okay, so this is 60. Okay, then 11 minimum, and in the numerical we have that plasticity index equal to 40. So these conditions are satisfied. But another headache we have here is that A7 group is further subdivided in A75 and A76 group, and for that we will use these equations. Okay, so now straight away moving to that numerical, you will see how to use these equations. Here it is. Okay, plasticity index, that is given over here, that is 40. Liquid limit minus 30, liquid limit is 60. So 60 minus 30 is 30, and it is 40. So this condition is satisfied. Okay, I hope you are getting this thing. So this condition is satisfied. So this is that first condition of the table, and it shows us that this is A76. Okay, this is that second condition. Okay, this is A76 group now. Okay, you can see, and by moving back to that group, here it is, you can see that this is plasticity index must be greater than liquid limit minus 30. So this is 40 and this is 60. So 60 minus 30, this is 30 and this is 40. So equation satisfies for the A76. So this soil is now classified under group A76. The next headache will be to calculate the group index. Okay, so group index should be calculated by this equation. This is that equation. Okay, so simply using this 95 over here, person passing through sieve number 200. Liquid limit is 60, so put 60 over here and 95 over here and then 40 over here. So you will get this 42. So the final soil classification for this soil sample will be A76, which is a group index for that is 42. So this is their complete designation of their soil now. Okay, according to AASHTO classification system. I hope you got that AASHTO classification system. Now moving to that unified classification system. So this is like first derived by Cassagrande, and they worked on it as in the World War II. They required to investigate the soils. Okay, and during that World War II era, the American Army Corps of Engineers actually conducted different experiments and classified the soil according to this classification system. So straight away going to that classification system, this is like here in this classification system, soil is basically divided in two groups: coarse soils and then fine soil. And in the fine we have clay and silt. Okay, in AASHTO classification system, the boundary for the fine and coarse sand is 35% passing through sieve number 200. But in unified classification system, that boundary is not 35. Here it is 50% passing through sieve number 200. So if we are having a fraction that is passing through the sieve number 200 and it is greater than 50%, then it will be fine. Okay, fine soil. And if it is like less than 50% of the fraction is passing through sieve number 200, then it will be coarse grained soil. Okay, so here it is. How we will classify the soil? As in the AASHTO classification system, we have that nomenclature A26, A27, A1, A2, A3. This type of nomenclature is used for classification of soil. Here the nomenclature is group symbol starts with a prefix G and S. Okay, in the coarse soil we will use G and S. G will be for gravel, S will be for sand. This is the first part of that nomenclature. Second, we will have this in the continuation with that G and S. That W will be for well graded, P will be for poorly graded, L will be for low plasticity, and H will be for high plasticity. Okay, and definitely low plasticity will liquid limit will be equal to less than 50, and again this will be more than 50 for high plasticity soil. Okay, fine soil again will be divided in different groups. That will be the group samples for that fine soil will be M, which is for inorganic silt, C for inorganic clay, O for organic clay, and PT is the sample used for peat, muck and highly organic soil. Okay, so the first thing you will look for is how much percentage of the soil is passing through sieve number 200. Okay, if it is greater than 50%, then it will be classified in the fine soil. Okay, if it is less than 50%, then it will be classified in. So unlike that AASHTO classification system, the boundary here is 50. Okay, here it is that table. I hope this is visible to you people. Okay, coarse grain soil, and this table is for this part of the table is for fine grain soil, much like to that of AASHTO classification system. Okay, then you will look for if it is clean gravels more than 50% and this is more than 40% passing through number 400. So this is like classification for the coarse soils. Okay, few more terms are discussed here. That is the Cu and Cc. This is the uniformity coefficient and this is that coefficient of gradation, Cc, and simply this can be calculated by Cu, which is d10 divided by d60 divided by d10, and Cc is d30 divided by d60 multiplied by d10. Okay, and d30 square as well. Okay, so this was discussed in chapter number 2, so you can go through these lectures to recall this idea of the coefficient of gradation and coefficient of uniformity coefficient. So if your soil is of this type that the uniformity coefficient is greater than or equal to 4 and the gradation coefficient is having a value between 1 and 3, including 1 and 3. Okay, so then it will be GW soil. So GW mean gravel well graded. Okay, again, if this condition is satisfied, like uniformity coefficient is less than 4 and the coefficient of gradation is less than 1, or coefficient of gradation is less than is greater than 3. Okay, so like you can say it is not falling in between 1 and 3. Okay, so then it will be GP soil. Okay, the group that is according to unified classification system will be GP. So GP mean gravel but poorly graded. Okay, poorly graded gravels. Similarly, again this is for gravel, and this is that organic silt. This is for clay. Okay, then again this is low plasticity organic clay. So again this is these are the classification system, and you can move through these tables. So you can see this is a very congested type of table, and on the first look you will see this is very complex type of table, how to use it, and you will think about it, but it is not like that. Okay, don't think negatively, think positive. This is a very simple table, just you have to use it wisely. Okay, this is very simple. You have to use plasticity index. Again and again these terms are like coming in on this course. Okay, and similarly this coefficient of uniformity coefficient and gradation and so on. Okay, so in the next class, inshallah, we will talk about the permeability, soil permeability. Okay, thank you very much for listening. Assalamu alaikum.